Morning, grade 11s. Today we're going to go through the first two problems on your gas stoichiometry lesson. So I believe lesson 5. So we'll go through the first two together as a class, and then the last four are your responsibility that you can go through. Again, we've done stoichiometry in solids, we've done it in solutions, now we're going to do it in gases. So a lot of these themes you're going to be seeing over and over and over again. Hopefully these are getting easier as we go through because we're just doing the same concept in a slightly different way. But I will go through these two with you before, so to help you go through the other four. Okay, so I'm going to close this up so I can get started here. Let's start with question 1. Okay, so it says calcium carbonate is heated strongly. And carbon dioxide gas is released according to the following equation. What volume of CO2 measured at STP is produced if 15.2 grams of CaCO3 is heated? Okay, so here's what we're going to do. We'll set up our equation. It is given to us. We should always check to make sure it's balanced. And now, because we've learned so many rules that are different for different types of compounds, we should be making sure you're putting in the states as well if they're given. Okay, so we have 1 calcium, 1 calcium, 1 carbon, 1 carbon, 3 oxygen, 3 oxygen. So we are balanced right now. So we're going to set up our stoichiometry table. How we're going to do this now, if you remember before, we did mass, moles, concentration, volume. We're going to add now, this can also be volume and molar volume now, okay, because we are going to be dealing with gases, okay? So this question says, what volume of CO2 gas, we're going to be looking at what volume of CO2 gas measured at STP is produced if 15.2 grams of CaCO3 is heated. So let's start. We're given in the question 15.2 grams of CaCO3. So I'm going to put that in for my mass. Okay, now we know we're going to have to figure out moles. Okay, so to do that, we're going to have to figure out what our molar mass is of CaCO3. So we know that's going to be the molar mass of calcium plus the molar mass of carbon plus 3 times the molar mass of oxygen. So if we look on our periodic table, that's going to be 40.08 grams per mole plus 12.01 grams per mole plus 3 times 16 grams per mole. Okay, put that in my calculator. .08 plus 12.01 plus 3 times 16 is going to give us a molar mass of 100.09 grams per mole. So I'll put that in for my molar mass. Okay. So we did learn, we know that if we're going down, we need to divide. So 15.2 divided by 100.09 is going to give us a number of moles. So it's going to be 0.015, sorry, no, 0.1519 moles. Now we want to know about carbon dioxide though. We can't use that mole ratio rule using volumes here because 1, we're not told in the question that it's constant pressure volume, and 2, this is a solid and this is a gas. Okay, so we're going to still have to do mole ratios like we did earlier in the year. So I'm going to try to figure out how many moles of CO2 I have. Okay, and I'll do that doing mole ratios. Okay. So for my mole ratios, I know my moles of CO2 is going to be my moles of CaCO3 times my mole ratios. Okay, so I'm going to have 0.1519 moles times 1 CO2 for every 1 CaCO3, so it's going to give me the same value. Oh, why do I keep putting a 0 in there? 0.1519 moles. Now, we're told in the question, that it's measured at STP. So we can actually use our molar volume here to figure out moles of a gas. So at STP, we learned last week that our molar volume is 22.4 liters a mole. Okay, and it says CO2 is measured at STP, so we can use our molar volume. And because we're going up, we can now multiply. So 0.1519 times 22.4 is going to give us our volume. Okay, so our answer is going to be here. And if I look at the question, I'm going to report this to 3 significant figures because that's how many is given to me in 15.2 grams. So I'm going to end up with 3.40. Oh, this doesn't want to. 3.40 liters. Okay. So that means I need 3.40 liters of carbon dioxide gas is going to be produced at STP if 15.2 grams of CaCO3 is heated. Okay. So same as what we've been doing before, just a little bit different because we now have gases. So let's do question number 2 together. So this says the synthesis of sodium chloride occurs according to the following reactions. Sodium plus chlorine makes sodium chloride. Okay, so I'll set up my equation first. So I have sodium, this is a solid, reacting with chlorine, which is a gas, to make sodium chloride, which is a solid. Now, if I look, this isn't balanced. To balance this, I need a 2 here and a 2 here. So don't assume that the question is given to you balanced. Okay, it may not be. I'm going to set up our table with volume or mass, molar volume or molar mass, moles, concentration, and volume. Okay. So it asks what volume of chlorine gas at STP. So we're going to look here. We're trying to figure out what volume is necessary for the complete reaction of 4.81 grams of sodium metal. So 4.81 grams is given to us here. So this is my mass. Okay. I need to know my molar mass. I can just look right off the periodic table because this isn't a compound. This is going to be 22.99 grams per mole. So if I divide 4.81 by 22.99, that's going to give me how many moles I have. So this is going to be 0.2092 moles. Okay, so to get from here to here, we need to use our mole ratios. So we're going to say our moles of chlorine. Oops, I'll do this in a different color so you see where that number is coming from. So our moles of chlorine is going to equal our moles of sodium times our mole ratio of chlorine over mole ratio of sodium. It's going to be 0.2092 moles times 1 chlorine for every 2 sodium. It's going to give me 0.1046 moles. So it's going to go in here. Okay, again, we're also told in this question, we're lucky that it's at STP. So we can use molar volumes like we did before, 22.4 liters. And it's going to give us our volume, and we'll report this to 3 significant figures, 2.34 liters. Okay, so pretty good. Now, keep in mind, we still can have limiting and excess reactants in reactions with a gas. We would do that the same as we did previously. We also may not always be given our reactions at STP or SATP. If not, you would just use ideal gas law, so our PV equals nRT, to figure out your moles or your pressure or your volume, whatever you're being asked to find. Okay. So those are 2 gas stoichiometry problems. So after this, you should be able to get through the other 4 questions. Okay. So 3, 4, 5, and 6. We'll post a PDF of the solution of these 2 questions, as well as this. You'll be able to follow along with this video tutorial. And if you're having problems, please reach out for extra help, either during my office hours or via email. Okay. Otherwise, hopefully you're all staying safe, staying healthy, and staying at home. Hopefully we'll see each other soon. Thanks so much.